Hi, hello, namaste my dear children. Welcome back to the lecture series of alcohol, phenols and ethers from Maharashtra Board Grade 12 Chemistry. This is the second video of the same chapter. In the video number 1, we covered the introduction, the classification of alcohols and the nomenclature of alcohols. In today's video, we are going to cover the preparation of alcohols. My name is 𝐒𝐿𝐵𝗲𝐵 and you are watching 𝐒𝐿𝐵𝗲 classes. Let's get started. So, we are starting with the preparation of alcohols. The first preparation is from alkyl halides. So, we all know that alkyl halides means it is RX. So, this is my alkyl halide. When alkyl halide is treated with aqueous NaOH, that means NaOH dissolved in water. In place of aqueous NaOH, you can also take aqueous 𝐂𝐤𝐤 as well. Aqueous 𝐂𝐤𝐤 also will have the same role as the aqueous NaOH has. So what does it do is it removes NaX from here because Na is having a lot of attraction towards the halogen. So the halogen will come with Na and ROH will combine together. So you get the product as ROH, this is our main product, and NaX, sodium halide is our byproduct. So this is alkyl halide. This is alkyl halide. When it is treated with aqueous NaOH or aqueous 𝐂𝐤, we get alcohol and sodium halide. Okay, so the byproduct is sodium halide. So I have taken an example here, CH3CH2Br, which is called as ethyl bromide. It is the bromide of 2 carbon atoms, so which is called as ethyl bromide, or the IUPAC name is bromoethane, treated with NaOH. So this NaBr will be coming out from here and you will be getting the product, which is your CH3CH2OH. The byproduct is NaBr. So what is the name of the main product? This is called as ethyl alcohol. So this is how we can prepare our alcohol. Second method is from moist silver oxide. So moist silver oxide means it is silver oxide along with water. So first of all, moist silver oxide will give you AgOH, that is silver hydroxide. When silver oxide reacts with water, it gives you silver hydroxide. So that's the main reagent over here. So this is my alkyl halide. I am treating this with AgOH. AgOH is coming from moist silver oxide. So what happens is AgX comes out and ROH combines together. So we get ROH, that's our alcohol, plus AgX is our byproduct. So this is my alcohol. See the example, CH3CH2Br, this is called as ethyl bromide again. I have taken ethyl bromide and that is treated with AgOH. So AgBr is coming out from here and you are getting CH3CH2OH plus AgBr as the byproduct. What is the name of this alcohol? It is ethyl alcohol. Okay. So these are the two ways by which we can get alcohol from alkyl halide. Let's start with the next preparation now. The next preparation is acid catalyzed hydration of alkenes. So it is basically hydration of alkenes. The meaning of hydration is hydroaddition. So hydration, the literal meaning of this is hydroaddition. And all of you know that hydro means what? Hydro means H2O or water addition. So this reaction is basically addition of water with alkene in presence of acid. So acid will be acting as a catalyst. So first we are taking alkene. Here I have taken the example of ethylene. This is my ethylene or ethene you can say. And that is reacted with the acid first, concentrated H2SO4. So we know that unsaturated compounds go for addition reaction. So here the addition will take place. H will get added to one carbon atom and HSO4 will get added to another carbon atom. So we get the product as CH3 single bond CH2.HSO4. So you can see this hydrogen got added to this CH2. So that has become CH3 and this CH2, this HSO4 got added to CH2. So we got CH2HSO4. So this is called as ethylene hydrogen sulfate. The name of this product is ethylene hydrogen sulfate. Okay. Now in the next step we are going to take this product ethylene hydrogen sulfate where we have taken here, and we are adding water now. So what happens is, again H2SO4 comes out like this. H2SO4 we get back, since it is as catalyst, so we will get back it as it is, and OH will get added to this. So we get CH3 CH2 OH plus H2SO4. So our main product is ethyl alcohol. So from ethene, by addition of water we got ethyl alcohol. This is my ethylene hydrogen sulfate. So there are two steps. First the acid is getting added, and then acid is coming out as it is and water is getting added. Let's see another example. This is propene. This is my propene, which is an unsymmetrical alcohol. So when the H and HSO4 will get added, this is H plus and this is HSO4 minus. So the addition will take place according to Markovnikov rule. So the negative part of the reagent will get added to that carbon atom which is having less number of hydrogen, and the positive part will get added to the carbon which is having more number of hydrogen, which is our Markovnikov rule. So first I get a product that is CH3 CH, HSO4 gets added over here, and this side I get CH3. So this is called as isopropyl hydrogen sulfate. The name of this compound is isopropyl hydrogen sulfate. Hydrogen sulfate. Why this is isopropyl? Because all of you know that this group is called as isopropyl group. So this is isopropyl hydrogen sulfate. Now in the next step I will take isopropyl hydrogen sulfate here, and I will be adding hydro, that is water. So what happens is this H2SO4 comes out and OH gets added over here. So we get CH3 CHOH CH3, and we get H2SO4 as it is. This is called as isopropyl alcohol. So this is isopropyl alcohol. So here you can see the ultimate addition of OH is according to Markovnikov rule. This is your propylene. So this carbon is having less number of hydrogen. So water, this is plus and this is minus. So negative part will get attached to this carbon atom. You can observe here this carbon atom, that is Markovnikov rule is followed. But this reaction happens in presence of acid. Acid catalyzed hydration of alkenes. Therefore the name is so. Come here. For this particular thing, this is a branched alkene, you can see. For here we can directly add water in presence of acid. Okay, so what happens is the OH part will get attached to this carbon atom which is having less number of hydrogen according to Markovnikov. So the OH part will get attached to this carbon and H will get attached to this carbon according to Markovnikov. So this is CH3 CH3, this side OH, and this is CH3. I'll just erase this, otherwise it will not be proper. So this is OH and this is CH3. So we got a tertiary alcohol. This is called as tertiary butyl alcohol. Okay, so this is how we can prepare alkene by acid catalyzed hydration of alkene. We can prepare alcohol, by the acid catalyzed hydration of alkene. So the third preparation of alcohol is from hydroboration oxidation of alkenes. Hydroboration oxidation. So here we treat the alkene with diborane. P2H6 is called as diborane. This is my ethylene. Again I am starting with ethylene, one of the alkene, the first member of alkene series, and this is called as diborane. This is diborane. So what happens is, here hydrogen gets attached to this carbon and boron gets attached to this carbon. Addition reaction again. Hydrogen gets attached to one carbon and boron gets attached to another carbon. So when hydrogen gets attached to one carbon, first carbon, you get CH3, then CH2. Now boron will get added. Boron is having valency 3. So this whole thing will be thrice and then boron. Boron gets added like this. Okay, now here there are 2 boron. So I put 2 over here to balance the entire equation. 2 CH3 CH2 whole thrice B. This is called as triethylborane. This is triethylborane we get. Okay. So now here CH3, this also will be 2 to balance it. So triethylborane we get. Now in the second step, this triethylborane is treated with hydrogen peroxide in presence of base. Okay. So what happens, see, this boron will come out with this OH. I'll just show you this, how this is happening. I'll just show you. This boron is coming out with OH. So you know that boron, the valency of boron is 3. So OH whole thrice it will be. So there are 3 OH, and because of that 3 OH, I am adding, I'll just rub this out so that you understand the balancing part. So OH, it has come out with 3 OH. Now oxygen is 3. So make it 3 over here. Now you can see 3 oxygen and 3 hydrogen is still left because 3 OH has come out with boron. This is boric acid actually. If you see, the structure of this is H3BO3, which is called as boric acid. We can write it H3BO3 or we can write it as BOH whole thrice. So 3 O and 3 H has gone with boron. Another 3 hydrogen and 3 oxygen is left, which will be reacting with this part. Okay. So we'll get CH3, CH2OH. Now this is also 3 and this alkyl part is also 3. So write down 3 over here. So this is how we get alcohol. This alcohol is ethyl alcohol. The important part over here is, first we get trialkylborane and then trialkylborane again reacted with H2O2 in presence of alkali to give you ethyl alcohol or alcohol. Here this is propene. Propene, now propene is an unsymmetrical alkene. B2H6 is getting added. So B will get added to this hydrogen and B will get added to this carbon and hydrogen will get added to one carbon. So first of all, suppose this hydrogen is getting added over here and B is getting added over here. So we are getting CH3, this is CH2 and CH2. Okay, CH3, CH2, CH2, that will be again thrice because the valency of boron is thrice. So we are getting tripropylborane. Now this tripropylborane is coming here reacting with H2O2 in presence of OH minus. So BOH minus is coming out as boric acid. Another 3 OH and 3 CH3, CH2, CH2 will give you propyl alcohol. This is propyl alcohol. So here also if you observe keenly, we can see here in the alkene, this alkene has converted into this one. There are 2 steps, but actually what is happening, the alkene is converted into alcohol. So it is the addition of water only. Okay, basically it is the addition of water, but if you see, the addition has taken place according to anti-Markovnikov rule. So this is what you need to remember, that we are preparing alcohol from alkene by 2 methods. The first method is acid catalyzed hydration, where the addition of water is taking place according to Markovnikov rule, and the second part is hydroboration oxidation of alkenes, where the addition of water is taking place according to anti-Markovnikov rule. So in case if you do not remember both the steps, then remember that when you are taking dibutane as a product, then addition of water will take place as per the anti-Markovnikov rule. Next reaction for the preparation of alcohol is from carbonyl compounds. So we know there are 3 carbonyl compounds: aldehydes, ketones and carboxylic acid. So we are going to see by reduction of aldehydes and ketones first. Okay, by reduction of aldehydes and ketones, which can be done by using nickel. That is, we are going to do hydrogenation in presence of nickel. In place of nickel, you can also use palladium or platinum. They have the same role. They are the catalyst over here. So I am taking aldehyde RCHO and hydrogen here. Okay, in presence of nickel, hydrogenation will take place. That is hydrogen addition. Hydrogen I am writing this way. One of the hydrogen will get added to oxygen and one of the hydrogen will get added to carbon. So what are you getting? R, CH is already there. One H is added. So RCH2. Carbon has got 2 hydrogen. And this oxygen has got 1 hydrogen, so RCH2OH. This is 1 degree alcohol you are getting. Sorry, this is 1 degree alcohol. From the aldehyde, you are getting 1 degree alcohol. This is the product. So we have taken a particular example, CH3CHO, which is called as acetaldehyde in presence of hydrogen in presence of nickel. Addition of hydrogen in presence of nickel. One of the hydrogen will get added to carbon and one of the hydrogen will get added to oxygen. So we get CH3CH2OH, that is ethyl alcohol. This is the product. Let's see the next part. This is ketone. Ketone, again addition of hydrogen is taking place. This is nothing but hydrogen in presence of nickel. hydrogen will get added to oxygen and this hydrogen will get added to carbon. So you get RCHOHR, RCHOHR. This is nothing but 2 degree alcohol. So the important part here is when we are using aldehyde in this case, we are getting a 1 degree alcohol. If you are using ketone, we are getting a 2 degree alcohol. This is an example. This is called as acetone. 3 carbon atoms ketone is called as acetone. Hydrogen. So one hydrogen gets attached to oxygen, one hydrogen gets attached to carbon. So you get CH3, CHOH, CH3, which is called as isopropyl alcohol, which is a 2 degree alcohol. So this is how we can prepare alcohol from aldehydes and ketones by the reduction using nickel, hydrogenation using nickel. Another method of reduction is using lithium aluminium hydride and followed by acidic hydrolysis. Even lithium aluminium hydride gives us or produces nascent hydrogen and which causes a reduction. But the problem is lithium aluminium hydride is a bit expensive. That is why we prefer the first reaction, that is reduction by hydrogenation using nickel. So how do we do this? This is your aldehyde. We are using lithium aluminium hydride followed by acidic hydrolysis, which gives rise to nascent hydrogen. Now this nascent hydrogen, one gets attached to oxygen and one hydrogen gets attached to carbon, and at the same time from aldehyde we are getting 1 degree alcohol. Similarly, this is the example, acetaldehyde. We are using lithium aluminium hydride in presence of H3O+, that is acidic hydrolysis followed by acidic hydrolysis basically. So one hydrogen gets attached to this oxygen, one gets attached to this carbon, and you are getting CH3, CH2OH, that is your ethyl alcohol. Okay, let's see the next this thing, ketone. With ketone, if you are doing the same reduction process using this using lithium aluminium hydride followed by H3O+. So one hydrogen attacks here and one hydrogen gets attached here. So we get RCHOHR, which is your 2 degree alcohol. So ketone gives us 2 degree alcohol and aldehyde gives us 1 degree alcohol. This is an example. This is called as acetone. This is acetone, and one hydrogen gets attached here, one hydrogen gets attached here. So we get CH3, CHOH, CH3. This is called as isopropyl alcohol, which is a 2 degree alcohol. Okay. So by reduction of carbonyl compounds, in that we have seen aldehyde and ketones reduction using 2 different reagents. One is hydrogenation in presence of nickel and the other one is lithium aluminium hydride followed by acidic hydrolysis. Another carbonyl compounds is your carboxylic acid. So this is your carboxylic acid, RCOOH. Lithium aluminium hydride plus H3O. What you do is break this bond. Break this bond and using 2 hydrogen from here and this oxygen gives you water. So that is a byproduct. 2 hydrogen from here and oxygen gives you water. Another 2 hydrogen will get attached to carbon because we have to fulfill the valency of carbon. So if oxygen gets out from here, carbon has 2 valency vacant. So those 2 valency will be fulfilled by 2 hydrogen. So accordingly we need 4 hydrogen which will be provided by lithium aluminium hydride followed by acidic hydrolysis. So if 2 hydrogen gets attached over here, you get 1 degree alcohol. This is the example, CH3CH3OOH. This is called as acetic acid. Acetic acid is the common name of this acid. You are using this thing, lithium aluminium hydride followed by acidic hydrolysis. This water along with 2 hydrogen, this oxygen along with 2 hydrogen will give you water, and this carbon will have 2 more hydrogen. So CH3, CH2OH, that is your ethyl alcohol is the product. So we get ethyl alcohol in this case. We have another alternative method for the preparation of alcohol from carboxylic acid. So that is RCOOH. This is your carboxylic acid, which reacts with alcohol. See, this is my alcohol in presence of concentrated acid, which acts as a catalyst. This reaction is called as esterification reaction because ester formation happens over here. So what happens is, from the carboxylic acid OH and from the alcohol H comes out as water molecule. So this is coming out as water molecule, and the rest of the part you just join. So you get RCOOR dash, which is called as ester. Okay. Now in the next step, ester is taken. This is my ester, and that is reduced with hydrogen in presence of nickel. So break this bond. This bond is broken. one of the hydrogen is given to this, so you get R-OH, that is you get your alcohol back. The alcohol which you have used in the first step, that you are getting here back. And this carbon, this one of the hydrogen you give to one oxygen and one of the hydrogen you give to this carbon. Because now what is left? I'll just show you here. I'll just rub this and show you here. What is left now? If R-O and one of the hydrogen is taken from here, it has given you R-OH. So what is left? R, C and O is left. So to fulfill the valence is give 2 hydrogen here and give one hydrogen here. So basically we are using 2 plus 1 plus 1, 4 hydrogens. So that 4 hydrogen will be coming out, or 4 atoms of hydrogen will be given by 2 molecules of hydrogen. So you have to use 2 molecules of hydrogen for the balancing purpose. Okay. Come here. This is CH3COH. This is called as acetic acid. And when this is reacting with ethanol or ethyl alcohol, okay, in the first step, what is happening? From the alcohol, the H, and from the acid, the OH is coming out as water. So that is water. Rest of the part you join. So CH3COOC2H5. CH3COOC2H5. This is called as ethyl acetate. The common name of this ester is ethyl acetate. Now this is the ethyl part and this part is the acetate part. Now in the next step, take the ethyl acetate here and react with hydrogen. So break this bond and this C2H5O will go with one hydrogen, C2H5OH. So you get your ethyl alcohol back over here. This is your ethyl alcohol back. Okay. And 2 hydrogen you will give here and 1 hydrogen you will give here. So you get CH3CH2OH. CH3CH2OH, that is your ethyl alcohol. So this is how we get alcohol from the carbonyl compounds. Now the last method for the preparation of alcohol, that is addition of Grignard reagent. By addition of Grignard reagent or by addition of aldehydes and ketones. Okay, so this one I'll just show you how it has to be done. So we are using Grignard reagent and the substrate is aldehyde or ketone. So aldehyde or ketone is reacting with Grignard reagent. So first of all, let me show you aldehyde. Okay. So first I'll take the general formula, that is I'm taking example only, ACHO. This is aldehyde with 1 carbon atom, which is called as formaldehyde. This is my formaldehyde. And suppose this is reacting with CH3MgBr. So you know that Mg is more electropositive than carbon. So this will be getting the positive charge and this carbon will be getting the negative charge. And here this oxygen is negative and this carbon is positive. So the negative will get attached to this carbon and the positive will get attached to this oxygen. So this reaction happens in presence of dry ether. Whenever you are taking Grignard reagent, remember the solvent is always dry ether. What we get is HC. The CH3 got attached to this carbon. This hydrogen is already there, and O minus gets attached to MgBr. So this is a complex. First of all, this is unstable. It is a complex. Now you will be treating this complex by HOH, that is water. So this is minus and this is plus again. The bond between OMg will be broken. The plus will come to negative and the minus will come to positive. Okay, so finally we will be getting HCCH3H. O will get hydrogen and the other byproduct is MgOHBr. So this is my product and you can see this is a 1 degree alcohol. This is called as ethyl alcohol, which is nothing but 1 degree alcohol. So in aldehyde, if we are using formaldehyde, we are getting 1 degree alcohol. Now let's see what happens if we are using acetaldehyde. Okay, so I'll clean it. I'll do it again. Suppose I am using acetaldehyde, CH3C double bond OH. This is my acetaldehyde. And I am treating this with CH3MgBr in presence of dry ether. Okay, so this is negative, this is positive. Here this is negative, this is positive. So the negative will add with the positive and positive you add with the negative. So what you get is CH3, C, this is CH3 over here, this is hydrogen, O minus MgBr plus. So this is the complex, and now this complex is treated with HOH. This is minus, this is plus. Break the bond between O and Mg and give the positive to the negative and positive to the negative to the positive. So you get CH3H. The bond between OMg is broken and H plus get attached to the oxygen and Mg takes OH. So you get this as the byproduct. What is this? This is isopropyl alcohol. This is isopropyl alcohol, and this is a 2-degree alcohol. So this is a 2-degree alcohol. So we have seen that if you are using formaldehyde as a substrate, then we are getting primary alcohol as a product with Grignard, and if you are using acetaldehyde as a substrate, then we are getting secondary. So with Grignard reagent, the conclusion will be, apart from formaldehyde, any other aldehyde you use, you will be getting secondary alcohol. So with formaldehyde, Grignard reagent will give you primary alcohol. Any other aldehyde apart from formaldehyde will give you secondary alcohol, and with ketone we are going to get a tertiary alcohol. So that's the reaction with Grignard. Now the last part, that is a summary of the whole thing, that is a preparation of alcohol. So first preparation we did from alkyl halide. The reaction was Rx plus aqueous NaOH was giving us this NaX will be coming out and will be getting alcohol plus sodium halide. Second reaction was from alkenes. From alkenes we have used two different methods. One is the acid catalyzed hydration of alkenes, where according to Markovnikov rule the water addition is taking place. Okay. Another one is hydrobodation oxidation reaction, where we are reacting the alkene with diborane, and there also the addition of water only is taking place, but that is happening according to anti-Markovnikov rule. The third preparation was from carbonyl compounds. The carbonyl compounds are aldehydes, ketones and carboxylic acids, and we used the reduction process for that, and the reduction we have done by using two different reducing agents. One is hydrogen in presence of nickel, and the other one is lithium aluminium hydride in presence of H2O plus. And there we have seen that aldehydes on reduction giving us primary alcohol, ketones on reduction giving us secondary alcohol. And also carboxylic, for the carboxylic acid part we have used another alternative method, that is the first esterification reaction, formation of ester followed by hydrolysis of it. Okay. The last one is with Grignard reagent, and when Grignard reagent is reacting with aldehyde and ketone, if you are using formaldehyde as a substrate, then we are getting only 1 degree alcohol as a product. Other than formaldehyde, all other aldehydes will be reacting with Grignard reagent to give you secondary alcohol as a product, and ketones will be reacting with Grignard reagent to give you tertiary alcohol as a product. So this is the whole summary of the preparation of alcohol. I hope everyone is clear with this topic now. So if you find these videos are beneficial for you, please subscribe the channel and press the like button. In the next video, I am going to come with physical properties of alcohol and the chemical properties of alcohol. Till that time, stay tuned. Thank you so much.